My dear students, welcome back to our channel. In this video, I will be explaining the MBA 4th semester subject Data Mining for Business as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Quick study tip. If time is short, first focus on long cues 1, 2, and 4 and short cues 1, 2, and 4. Use flowcharts and real-world examples like customer data, sales records, product categories to make answers easy to remember and explain in Viva. Unit 1 first important short question is Data cleaning. Answer. Data cleaning is the process of removing or correcting wrong, incomplete, or duplicate data from a dataset. When businesses collect data from sources like online forms, customer records, or surveys, it often has errors such as missing values, example, no email or phone number. Wrong data, example, age entered as 500. Duplicate entries, same customer added twice. Spelling mistakes, example, India instead of India. If data is not cleaned, the analysis will give wrong results, which leads to bad business decisions. Example. A retail company collects customer orders. One order has no address, another has the same name twice. These need to be cleaned to avoid delivery errors. Easy tip to remember. Dirty data is equal to wrong decisions. Clean data is equal to smart business. Data cleaning is like washing vegetables before cooking, necessary and useful. Next important short question is 2. Data reduction. Answer. Data reduction means reducing the size of data while keeping the most important information. It helps in faster data mining and saves storage space. When we work with large datasets, like customer details, sales records, or web logs, many values may be repeated, irrelevant, or too detailed. Data reduction removes or combines this extra data. Types of data reduction. Attribute reduction, remove unnecessary columns. Data compression, use fewer bits to store data. Dimensionality reduction, reduce number of features. Sampling, use a small part of data that represents the whole. Example. A shopping app has 10 lakh customer records. Instead of using all, it picks 10,000 that represent different age groups and locations. This is sampling. Easy tip to remember. Less data, same result is equal to data reduction. It's like zipping a file, smaller but useful. Next important short question is 3. Feature extraction. Answer. Feature extraction is the process of picking important information, features, from raw data to help in better analysis. In data mining, we often deal with large, complex data like images, text, or customer records. Not all parts of the data are useful. Feature extraction converts this raw data into a simpler and useful format. Example. In a facial recognition system, a full photo has millions of pixels. But only key points like eyes, nose, and mouth shape are extracted as features. This reduces complexity but keeps important information. In business, from a customer's full profile, features like age, spending amount, and purchase frequency are extracted for analysis. Easy tip to remember. Extract only what matters. Like making juice from fruits, you take the best part and leave the rest. Feature extraction helps make faster, smarter decisions. Next important short question is 4. Data discretization. Answer. Data discretization means converting continuous, numeric, data into fixed categories or ranges. It helps make complex data easier to understand and analyze. Many data mining algorithms work better with categorized data instead of raw numbers. Example. Let's say a supermarket has customer ages like 21, 35, 42, 67, etc. Using discretization, we can group them as 18 to 30 young, 31 to 50 middle-aged, 51 plus senior. So instead of exact ages, we use categories. This helps in making decisions like offering different products to different age groups. Why it's useful? Reduces complexity. Improves accuracy in data mining models. Helps in clear decision making. Easy tip to remember. Discretization is equal to divide and categorize. Like grouping exam marks into grades A, B, C. It makes raw numbers more meaningful for business. Next unit 2. Long questions. First important long question is data preprocessing. Answer. Data preprocessing is the first and most important step in data mining. It means preparing raw data so that it becomes clean, consistent, and ready for analysis. Raw data collected from various sources like websites, surveys, apps, or sensors may contain errors, missing values, duplicates, and inconsistencies. If we use such data directly, the results of data mining will be wrong. Main steps in data preprocessing. 1. Data cleaning. Fixes errors, removes duplicates, and fills missing values. Example. Correcting a mobile number entered as 99999XXXXX or filling a missing city name. 2. Data integration. Combines data from multiple sources into one. Example, merging customer data from website and mobile app. 3. Data transformation. Converts data into a proper format or structure. Example, converting all dates into the same format, DDMMYYYY. 4. Data reduction. Reduces the size of the data without losing important information. Example, selecting only important columns like age, income, and purchase amount. 5. Data discretization. Converts continuous data into categories. Example, age 25 young, age 60 senior. 6. Feature extraction and transformation. Identifies the most important parts of the data and changes them into new useful forms. Example, from a transaction log, extracting total spend per customer. 7. Concept hierarchy generation. Organizes data into levels like city, state, country. Helps in grouping and summarizing. Example in business. An e-commerce company wants to analyze customer behavior. But first, it must clean errors, merge data from app website, group age ranges, and extract useful features. This is all part of preprocessing. Easy tip to remember. Good preprocessing is equal to good mining results. It's like washing and cutting vegetables before cooking, necessary for best results. Next important long question is 2. Data integration and transformation. Answer. Data integration and data transformation are key steps in data preprocessing. They help make data complete, consistent, and ready for mining. 1. Data integration. Data integration means combining data from multiple sources into a single, useful dataset. In businesses, data comes from websites, mobile apps, branch offices, social media, Excel files or databases. These sources may have different formats or values. Integration brings them together into one table or database. Example: a retail company collects customer details from both its website and physical stores. Integration combines both datasets into one system without duplicates. 2. Data transformation. Data transformation means converting the data into a proper format or structure. It includes normalization, bringing values to the same scale, example, converting prices from lakhs to thousands. Smoothing, removing noise from data. Aggregation. Summarizing data, example, total sales per month. Encoding, converting text data into numbers for analysis. Format conversion, changing data types, example, date formats or text to numbers. Example: a company may store dates as DDMMYYYY in one system and MMDDYYYY in another. Transformation converts all dates into a common format. Why are they important? They improve data quality, reduce inconsistencies and errors, help in building accurate data mining models, ensure smooth analysis and reporting. Easy tip to remember: integration is equal to combine. Transformation is equal to convert. Like combining ingredients from different shops, integration, and chopping them for cooking, transformation. These steps make data structured, clean, and useful for smart business decisions. Next important long question is: 3. Data summarization. Answer: data summarization is the process of presenting large amounts of data in a compact and meaningful way. It helps in understanding patterns, trends, and important insights without reading every record. Instead of analyzing every single row, we summarize the data to get an overall picture. This is useful when dealing with big datasets. Common methods of data summarization. 1. Statistical measures like mean, average, median, mode, min, max, standard deviation. Example: average monthly sales of a product. 2. Frequency counts, how often a value occurs. Example: how many times Hyderabad appears in the city column. 3. Grouping and aggregation, group data and calculate totals or averages. Example: total revenue generated per product or per region. 4. Data cubes and OLAP, used in business intelligence to summarize data in multiple dimensions. Example: sales data summarized by region, time, and product. Real-life example: an e-commerce company has millions of transactions. Instead of checking each one, it creates a summary like: month total orders, average order value. Jan 25,000 1,200 rupees. Feb 27,500 1,300 rupees. This helps managers quickly understand sales trends and make smart decisions. Why is it important? Saves time and effort. Makes data easy to understand. Supports quick decision-making. Helps in identifying key trends. Easy tip to remember: summarization is equal to short story of big data. Like reading the summary of a movie instead of watching the full 3 hours. Data summarization helps businesses get useful insights fast without going through every detail. Next important long question is: 4. Feature transformation. Answer: feature transformation is the process of changing the format or structure of data features, columns, to make them more useful for analysis or data mining. Sometimes, the raw data we collect is not directly usable. So, we transform or modify features to improve accuracy and performance of models like classification, clustering, etc. Why do we transform features? To remove noise or errors. To bring features into the same scale. To create better patterns for analysis. To make models run faster and perform better. Types of feature transformation. 1. Normalization. Converts all values to a similar scale, usually between 2000 and 1. Example, income values like 10,000 rupees and 10 lakhs rupees are normalized so both are on the same level. 2. Standardization. Makes data follow a standard format, mean is equal to 0, standard deviation is equal to 1. 3. Encoding. Converts text, categorical, data into numbers. Example, gender column. Male is equal to 0, female is equal to 1. 4. Log transformation. Reduces the effect of large numbers or outliers. Example, if one customer spent 1 lakh rupees and most others spent 1000 rupees to 5000 rupees, this helps balance the data. Example in business. In a supermarket dataset, the product category column may have values like fruits, electronics, clothing. To use it in machine learning, we encode it into numbers. Fruits is equal to 1. Electronics is equal to 2. Clothing is equal to 3. We also normalize sales values so that 500 rupees and 50,000 rupees are compared fairly. Easy tip to remember. Feature transformation is equal to change the shape, not the meaning. Like resizing a photo, it's still the same image but fits better. Feature transformation makes data more machine-friendly and improves the quality of analysis. Next important long question is 5. Concept hierarchy generation. Answer. Concept hierarchy generation is the process of organizing data into different levels, from general to specific. It helps in grouping, summarizing, and analyzing data more easily. In data mining, we often work with a lot of detailed data. Concept hierarchies help us move from low-level data to high-level categories. Why is it important? Makes complex data easier to understand. Helps in data summarization. Useful in OLAP, online analytical processing. Makes patterns more visible for decision-making. Real-life example. Let's say we have a column, city. We can create a concept hierarchy like city, state, country. So, Hyderabad, Telangana, India. Mumbai, Maharashtra, India. Chennai, Tamil Nadu, India. This helps us group customers or sales by state or country, not just city. Another example. Product category department. iPhone, smartphones, electronics. Kurti, women's wear clothing. Types of concept hierarchies. 1. Schema-based, defined using database schema, example, date, month, year. 2. Rule-based, defined using business logic or if-else rules. 3. Data-driven, built using clustering or statistical methods. Applications in business. Summarizing sales by region instead of city. Analyzing customer spending by product type instead of individual products. Creating dashboards that show higher-level reports. Easy tip to remember. Hierarchy is equal to step-by-step grouping. Like going from college-university education system. It helps managers and analysts see the big picture without going into unnecessary details.